Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to brand new season of the ISNET podcast. Season 2 starts now. I am Sadaf Sajat, Administrator ISNET, and today our episode shall highlight how cutting-edge space technology can protect our planet. Our guest is Dr. Mohammed Dabboor, a remote sensing scientist whose groundbreaking work with synthetic aperture radar SAR has influenced disaster relief, agriculture, water management, and more. He is also a senior member of the Institute of Electrical and Electronics Engineer, IEEE. Importantly, Dr. Dabboor has also been an active contributor to ISNET, participating in our workshops and training. So we are thrilled to bring his insights to you today. Dr. Dabboor, welcome. It's a real pleasure to have you with us.
Thank you very much, and thank you for the invitation.
So let's begin by setting the stage for our listeners. Synthetic Aperture Radar, or SAR, isn't just another satellite tool. It's a game changer. So for listeners who aren't specialists, can you explain what makes SAR stand apart from optical imagery and why those unique features are vital for climate resilience work?
Okay, that's a perfect question. Thank you again for this invitation. So SAR stands for, as you mentioned perfectly, Synthetic Aperture Radar. It's a remote sensing tool, very important, very crucial for Earth observation and for climate change. It's active remote sensing technology, unlike optical remote sensing. What's makes SAR unique as a technology is the fact that it's independent of the sunlight, so we can capture images day and night. Also, it's independent of the weather conditions. So even in the case of cloud, we can still get images, and we can still day and night 24/7 monitor our Earth and our planet. Also, SAR remote sensing is not just capturing images. We send a signal. This signal interact with the radar target, so we can get information about the electric properties of the target. We can get information about the structure or the geometry of the target. Also, we can get information about the moisture of the target. For example, sensing the soil moisture. So I would say a unique remote sensing tool which empower our capabilities for Earth observation.
Thank you. Sounds like a perfect remote sensing tool. So, Dr. Dabboor, if we can now discuss real world impact story, your research has consequences in the real life also. So can you share a standout example where SAR data directly saved lives or resources, like say in flood response, crop monitoring, or managing water supplies? Can you share your experience?
Sure. Yeah, for sure. So SAR remote sensing is very important in different applications, including emergency response. I think a very good example was the example of the flooding in Pakistan in 2022, where I guess more than 1,500 people died in this unfortunately disaster. So SAR was important, and I actually yesterday I was looking at the archive of the RadarSat Constellation mission, the Canadian mission, and I found that we did take images over Pakistan during the flooding to support the emergency response of the government for helping people or saving lives as well. So SAR remote sensing is important in these cases, especially having in mind that usually with in the case of flooding, the sky is cloudy. So optical remote sensing is not the perfect tool for near real time mapping of the flooding, which is important, to save life and save communities. So this is we see frequently this problem with the flooding, not only in Pakistan, but also even here in Canada and in Europe as well. So SAR is, I would say, is the crucial technology for flooding response. Another example is the monitoring of the soil moisture. This is very important in line of the climate change and in line of cases of droughts and even for the flooding as well. So we need, in order to prepare for risk of flooding, we need to know the moisture of the soil. So we use SAR for that. And we use SAR also for the mapping of the soil moisture and the variability of the soil moisture, and how this would impact also irrigation strategies as well. So this is also important for farmers. So I can I can speak hours, I think,
Yes.
about applications and case studies and success stories related to SAR remote sensing.
I'm sure
We
there are.
use it. We use it. By the way, I think I should, since I am calling from Canada, I
Yes.
think it's important to mention the ice.
Ah,
So we use SAR remote sensing for monitoring and mapping sea ice in the Canadian North, in the Canadian Arctic. Um, I think it's interesting to mention that for example, in 2023, we acquired more than 50,000 SAR images from the Canadian SAR satellites just to map the sea ice.
oh, that's
Yes.
yes, that's wow.
Yeah. So I mean, it's important technology, I guess, that's useful for us.
Yes, and I think with the passage of time, it's now becoming essential uh, for countries to monitor climate change.
Yes, yes, and I am hoping that developing countries will take a look on this technology and will try to build a capacity, a capacity building or expertise in this technology, so that we can leverage the fact that the accessibility to SAR data is easier, I would say, now compared to the past years. There are different satellites, even Canadian satellites
Mm.
and European satellites as well, where you can get free data. Also, the tools and some software packages are also free. So what's remaining, I guess, is the knowledge on how to process this data and how to leverage the information, because let's be honest, it's not the what we see in optical images. So we need expertise. We need to understand this data in order to make use to the maximum
Yes,
of the
and
information that we
yes,
get.
I agree. And this innovation shouldn't be limited to a few countries. We should make it accessible to developing nations as well. So, can you elaborate further that what hurdles still need to be overcome to democratize this powerful tool?
Yeah, as I mentioned before, compared to the past, data from SAR satellites are much more accessible. This started with the Copernicus space program of the European Space Agency.
Mm.
Also, Canada now is providing data accessible to the public, also with tools that can be used to process this data. So the data is there, the tools to process data is there, but we need in developing countries to focus more on the training
Mm-hmm.
Of the people to make use of this data. Also, we need to look at the infrastructure, the computing resources. Now the amount of images or the amount of data that we get from these satellites is huge. So
Yes.
we need strong computing resources. We need to look at the cloud computing as well in order to be able to process this data and extract information. It's important actually to mention also the AI, the artificial intelligence, and the importance of this technology to leverage to the maximum or get deep insights on the information or on our Earth system.
So,
Yeah.
if you can elaborate further on SAR combining with AI, machine learning, big data, as you just said. So, on the ground, to paint a fuller picture of our changing climate, how do we see combining SAR with these latest technologies?
Yes, although SAR is by itself is a powerful technology, but leveraging SAR with AI would give us, as I mentioned before, deeper insights on the information. So with AI, we can, for example, detect patterns
Hmm.
within a time series of SAR images that would tell us something about the climate and about the our about our Earth observation data. So this is important, and also with the ground data, we can validate this information. So combining the SAR images, the images from space, with the AI and with the ground observation, we can get a full picture of the story, a full picture of the climate, a full picture of the situation related to the climate change.
Okay.
Yeah.
So, what upcoming SAR missions or technological breakthroughs get you most excited about enhancing climate resilience over the next decade?
Yes, so I am excited a lot with upcoming SAR missions. We are already preparing for the next generation of the RadarSat constellation mission, the RadarSat program.
Okay.
Also, we I'm looking at next SAR missions, which are beyond what we already used to in terms of frequency. So I see trend in multi-frequency SAR missions. I see trend in improved SAR information in terms of polarization, for example. Also, I see new SAR missions coming with new kind of configurations of radar configuration with technologies like cross-track interferometry, along-track interferometry. Cross-track interferometry is very important, and we have already relatively newly satellite which was launched recently. It's called SWAT, the Service Water and Ocean Topography.
Mhm.
It's a collaboration between NASA and the French Space Agency with contribution from Canada as well, where we don't just get images. We get basically 3D information about the ocean, about the inland water bodies. So we don't limit us to just images. We see also elevations as well. So what my message is that we are moving fast with new technologies, with new architectures of SAR data, SAR satellites, and I think the future will be exciting.
Yes, inshallah. And if you can, to conclude, if you can share with our audience any upcoming related events that they should look about, and if how they can understand more about SAR's potential.
Yes. For the upcoming events, I would say we have two important upcoming events. One in Australia, the International Remote Sensing Geoscience and Remote Sensing Symposium,
Hmm.
IGERS. This is, I would say, this is the main SAR conference. I encourage our audience to, if possible, to attend this conference, or look at the preceding papers coming out of this conference. It's an annual event, and it's a huge event for SAR enthusiasts. Also, another event is the Living Planet, which is held by the European Space Agency every 3 years. This year, it's gonna be in Austria. I will be there as well. I will be presenting about SAR, and I will be happy to meet anyone from ISNET, anyone from our audience there. And it's a big event which include also state of the art SAR results.
Great. So, inshallah, our audience will also
Yeah.
look further into it. So, Dr. Dabboor, thank you so much for your vivid examples, expert insights, and inspiring vision. It's clear that SAR isn't just about imagery, it's about safeguarding communities and guiding decision makers towards smarter, faster responses to climate change. Thank you once again, Dr. Dabboor. I know the time difference was a bit odd, but still you managed and accepted our invitation. Thank you so much.
Thank you very much. Thank you for the invitation. Have a
Thank you
good
so
day.
much. And for our audience, we have included links in the show notes to Dr. Dabboor's key publications. You can see and access it. And if this episode sparked your interest, please share it with your networks and leave us a review. That's a wrap on episode 1 of season 2. Stay tuned for more conversations with leaders who are pushing the boundaries of space science to serve humanity and our planet. Thank you for watching. Have a nice day. Goodbye, Dr. Dabboor.